Hello guys, give me 1 second actually. Okay, so hi guys. So in this video, what I want to do is go over the power rule for derivatives. Um, I did do a few examples on the last video over um, over kind of how to do, you know, um, the definition of a derivative using the difference quotient. And so now what I want to do is I want to go ahead and go over actually how to do power rule for derivatives. And then there's another one that that there's a derivative of a constant that I want to look at as well. And so basically I'm going to just first start off with actually actually defining the power rule for derivatives. So basically the power rule, for derivatives is the following. So we have d dx of x raised to some number n such that n does not equal, or let's say n does not equal 0, right? Is equal to nx, so it's going to be nx to the n minus 1. So this is the power rule. So this is the power rule for derivatives, and what I want to do in this video is I want to go over some examples on how to do this. And there's another one, there's the constant rule. So the constant rule, let me try to write that better. For derivatives, and that is going to be that's going to be the following. So it's going to be d dx is equal to, or of some constant c is actually equal to 0. So the reason for that is that when you graph a function y equals some constant c, let's just kind of do this, and and basically the constant, let's say it's a horizontal line, you can see clearly, if you remember from algebra, this has a slope of 0. So really derivative is slope, right? That's another thing I want to say, is that derivative is slope, or rate of change. Some call it instantaneous rate of change. Yeah, so basically I want to go ahead and use these rules to do a few examples, and we're going to go ahead and go over some examples. So okay, so I want to go over this example, and by the way guys, there's certain properties as well. I just want to list those out before we get started, because these are very important. So for example, if we have two things, let's just say f of x, so the derivative d dx of f of x plus or minus g of x. This is equal to d dx of f of x plus d dx of plus or minus d dx of g of x. Okay, so basically this is kind of the addition property. It goes the same for subtraction as well. So I want to kind of point that out. And let's see. And we can also, so basically there's also the constant rule. So the constant rule, which is another one, this is like the same as, it's basically a constant multiple rule, I want to call it. I think that's what it's called. Yeah, constant multiple rule. And it's basically d dx of some number c times f of x is equal to c, and actually it's not the right color, is equal to sorry guys, give me a second, I don't know why, is equal to c times the derivative of f of x. And by the way that we call, if we call the, by the way, the way that we say the derivative of f of x, d dx of f of x, is really f prime of x. Okay, this is read as f prime of x. Okay, and this is read as d dx. Okay, so that's basically how we say that. So I just wanted to point that out. But anyways, we're gonna do this first one. So basically using this rule, number one, it says f of x equals 3x plus 1. Or what was it? Yeah, 3x plus 1. And we're gonna do f prime of x. So f prime of x. And we know that the derivative, so basically d dx of some, also the derivative of some, let's say some, some number a times x is really just a. Okay, so that's another one I want to point out, and it's basically just because the slope of x is 1. The slope of x, y equals x equals 1. So I want to point that out, right? Now I know that basically this is going to be, so the slope of 3x is going to be d dx of 3x plus d dx of 1. And like we said, the derivative of a constant, I think did I put it in? Yeah, the derivative of a constant, remember, is 0. So basically, and we know that the derivative of 3x, it's basically, what is the slope of 3x? It's just 3. So really, this is going to be 3, and then plus the derivative of this stuff here. And remember that 1 is a constant, so basically it's going to be plus 0. So we have, so basically this is 3, and then this part is 0. So basically so then f prime of x is just going to be 3. And that's our answer, right? I'm going to do another one. Let me just kind of, write a different one. Give me 1 second. All right, so this is another example. So I'm going to just write it down again. F of x equals 2x squared plus 4x minus 9. And we want to know the derivative of prime of x, right? So basically, again, we're going to do the derivative. So we're going to do d dx of 2x squared and then plus, and it's going to be d dx of 4x, and then plus, and then minus, so it's going to be minus d dx of 9, so basically of 9. So, I mean, you want to do it step by step. So obviously, like we said, there's the power rule, right? When we look at this one here, and look at this one right here, so basically d dx of 2x squared, so let's do 2x squared. This is really equal to d dx of 2x squared. And remember when we said basically the derivative of the power rule for derivatives says that d dx of ax to the n is equal to a times d dx of x raised to some power n, which equals a times, and we're going to do the following: nx, and then subtract, raise it to the n minus 1 power. So really, the way that I remember all this is I always put the 2, and then I just, do that. So that's a good way to kind of memorize that. So basically, this is going to be, it's going to be 2 times 2x, and then to the 2 minus 1. So basically, this is going to be equal to 4x, and then 2 minus 1 is just 1, so that's just going to be 4x. So that's the derivative of this, right? And then the derivative, d dx of 4x, is really just going to be 4, because that's the slope of 4x, right? And then finally, the derivative of 9 is just 0, because it's a constant, right? So then that means that f prime of x, if we put it all together, is d dx of 2x squared plus d dx of 4x minus d dx of 9. So then this is going to be, so like I said, this is considered 4x, so we have 4x, and then this is going to be this part right here, which we have right here, is just going to be 4. So then we have 4x plus 4, and then minus 0, so it's just going to be 4x plus 4 equals f prime of x. So that'll be our answer, right? So that's how you do that one. Let's go over another one. Let's do a little bit of a harder one this time. Let's do f of x equals x to the 4th power minus 3x cubed plus 4x squared minus 6x plus 2. So this is, again, a polynomial. So basically we're going to do, so we're going to bring this down. So it's going to be 4x. So really we have f prime of x. It's going to be 4x to the 4 minus 1. So basically to the 4 minus 1. And then this 3 is going to move down. So, and then it's going to be minus, it's going to be 3 times 3x to the 3 minus 1, and then plus, and then we have this right here, 2, we're going to move that down, so 2 times, and it's going to be 4x to the 2 minus 1. And then the derivative of 6x is just 6 minus 6. And then the derivative of 2 is just 0. So basically we just put plus 0 because it's just, that's the derivative of a constant. So then f prime of x becomes 4x cubed minus 9x squared plus 8x minus 6. So then this is our derivative for this function, right? Okay, and now what we want to do is we want to look at some derivatives that we know for a fact that we can use the power rule for them, but they're disguised as rational functions, right? So so really, like for example, 1, so let's do, let me do 1 over x cubed. And this is, like I said, f of x equals 1 over x cubed. And so basically what we want to do here is we know that we can still use the power rule for derivatives. But again, it looks like a rational. So we don't, for those of you that do know quotient rule, even though I haven't really gone over that yet, we're not really going to use that. You can use power rule for this. So basically, if you remember from algebra, 1 over a to the m is really equal to a to the negative m, right? So really, if I rewrite this, I can say f of x equals x to the negative 3 power. And now I can use power rule to do this. So we want to find the derivative, so then f prime of x is really going to be, so we have f of x is x to the negative 3. And then so f prime of x is really, we're going to move this down, so it's going to be negative 3 times x, and then we're going to subtract 1 to the exponent, so negative to the negative 3 minus 1. So then f prime of x just becomes negative 3x to the negative 4. You can always write it as like with positive exponents. So if you want to do that, really, you know that x to the negative n is 1 over x to the n. So we know that x to the negative 4 would be 1 over x to the 4th. And so it'd be negative 3 over x to the 4th. But either way, it would be right. I mean, it depends on your professor or your teacher, but either way would be right. So, and then there was another one that I wanted to go over, which was the square root function. So, if you look at, for example, f of x is equal to the square root of x. Well, in reality, we know that we can use power rule for this. If you remember from algebra, the equation or the square root function. So if I say the nth root of, and it's going to be of a, so let's do the nth root of, oh Lord have mercy, Sorry guys, give me a second. Okay. The nth root of, let's do a raised to some power m is really equal to a raised to the m over n power. Now, if you know about square roots, you know that square roots, the square root of a is equal to b if and only if b squared equals a, right? So really, if you think about it, I mean, we don't put a square root like this, but for this sake, I'll do it. So really, it looks like the square root of x, and then this is raised to some power 1, right? So really, this is like a 1 here. I'm trying to write it. So if I have x raised to some power 1, we're going to have, this is going to be really x to the 1 over 2. Okay, actually, I'm just going to put, we'll just do this because I don't want to confuse anybody. We'll do, there we go. So if we use the power rule for this, we know that f prime of x is going to be, so we know that it's going to be, we know that f of x actually is x raised to the 1/2 power. So then that means that f prime of x, we're going to grab this, we're going to move it over here, so 1/2, bring it down, and then times x, and then we're going to say to the 1/2 minus 1, right? And then basically this becomes 1/2, and then x, and then 1/2 minus 1 is negative 1/2. So then we know that this becomes 1/2 times times x, and then it's gonna be, so if you wanna do it with positive exponents or positive square roots, basically we're gonna do, so we have x to the negative 1 power over 2. So again, if you want to rewrite it like with positive square roots and all that stuff, or with square root radical form, it's really 1/2 times, and it's going to be the square root, so it's going to look like this, the square root of x raised to the negative 1. And what will happen here is that we're going to have 1 over 2 times, and we know that the square root of x to the negative 1, really, it's going to be the square root of 1 over x to the first power. So really, this is going to look like this. And since this is a square root, we know that this is equal to the square root of a over, it's really like this, hold on, like that. It's like the square root of a, the square root of a over b, right? And so we know that this is going to be the square root of a, square root of a over the square root of b, which is, so really this is going to look like this, 1/2 times the square root of 1 over the square root of x, which is equal to 1 over the square root of x, times 1/2, because we're multiplying the 1/2. So really this becomes 1 over 2 square root x. And this is my derivative, f prime of x, right? So that is the idea of power rule, guys. I don't want to make this video way too long, so I'm going to stop right here. And with that being said, guys, if anybody does have any questions whatsoever, please let me know, and also please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.